Good morning. I am Dr. N. Satish Kumar. I am going to handle the subject Digital Electronics and Logic Design. The subject code of our subject is 19A04304. Our subject consists of 5 units. First, we are going to see the first unit. The first unit is having three main topics. The first main topic is number system and codes. Second main topic is Boolean algebra and logic gates. And third main topic is minimization of Boolean function. Before going into the subject, first we are going to see the introduction. What is electronics? Electronics means study of flow of electrons in electronic circuits. Electronics is broadly classified into two categories. One is analog electronics and the next one is digital electronics. Analog electronics deals with analog signals. Analog signals varies continuously with time. Digital electronics deals with digital signal and digital signals are discrete in nature. Examples of analog signals are the voice signal, the electric signal, and the bioelectric signals generated by living things. These are examples of analog signal. Example of digital signal is temperature recorded every day in the morning at 8 a.m. is an example of digital signal. Now here we are having two waveforms. One is the analog waveform and the next one is a digital waveform. In analog waveform, at each instant of time, we are having the value for t. At each instant of time, we are having value, we are having some value, some voltage. But when you come to digital signal, at 0, it is having value, and it is having value at 1, and it is having value at 2. But between 0 and 1, it is not having any value. So it is discrete in nature. Now, digital electronics. Digital electronics uses binary numbers. Bi means 2. So it uses two numbers, 1 and 0, to represent information. Digital electronic circuits are made from large assemblies of logic gates. This digital electronics are made by logic gates. So what is logic gate? Logic gate is an electronic circuit. It is having only one output and it can have one or more than one input, and it will perform logic function. The logic functions are and, or, and not. These are the logic function. Now we are going to see the advantages of digital electronics. First advantage of digital electronics is it is easier to design. The second advantage is information storage is easy. We can store the information very easily. The third one is the accuracy and precision are greater in digital electronic circuits. Then digital electronic circuits are less affected by noise. Finally, more digital circuit can be fabricated on IC chips. Now we are going to see the first unit. And the first topic of our first unit is number system and codes. Now, what is a number system? Number system can be defined as the method or format which is used for denoting a numerical value. In order to denote a numerical value, we are using some format, and that format is nothing called number system. Types of number system. There are many types of number system. They are, first one is the decimal number system, second one binary number system, third one octal number system, and the fourth one is hexadecimal number system. Now, first we are going to see what is base or radix. The radix or base is a number of unique digits, including the digit 0 used to represent numbers. What is base? Base is the number of unique digits which is used to represent the numbers, and we are including 0 also. So decimal number system is having a base or radix as 10, and the numbers are from 0 to 9 in decimal number system. In binary number system, we are using the base 2 and we are using the numbers 0 and 1. In octal number system, we are using the base 8 and we are using the numbers from 0 to 7. Hexadecimal number system uses the base 16. Here we are having the numbers from 0 to 15. Example. Now this 1234 to the base 10. The decimal number system, in decimal number system we are using the base as 10, and in decimal number system we will be using the numbers from 0 to 9. Now we are now the value of this number is 1234. How we are saying this as 1334? Now this is the first position and this is the second position and this is the third position and this is the fourth position, and here each position is having a weight. This first position is having a weight of 10 to the power 0 and second position is having a weight of 10 to the power 1 and third position is having a weight of 10 to the power 2 and the fourth position is having a weight of 10 to the power 3. So multiplying these numbers with its weight, positional weight, we will be getting, and adding the numbers, we will be getting the total value. Now this 4 is nothing but 4 into 10 to the power 0. This 3 is nothing but 3 into 10 to the power 1. And this 2 is nothing but 2 into 10 to the power 2. And this 1 is nothing but 1 into 10 to the power 3. So we are adding the particular number with its positional weights. We are multiplying this number with its positional weights and we are adding all the thing and we'll be getting the number 1234. So how we are getting 1234 means this is 4. 4 into 10 to the power 0 is 4. 3 into 10 to the power 1 is 30. 2 into 10 to the power 2 is 200. And 10 to the 1 into 10 to the power 3 is 1000. So 1000 plus 200 plus 30 plus 4. That is nothing but 1234. Now we are going to see what is weight. In number system, weight denotes the positional value of each digit in number. It is a positional weight of each digit in number. Now we are taking this value 3125. This number 5 is having a positional value of 10 to the power 0. This 2 is having a positional value of 10 to the power 1. And this 1 is having a positional value of 10 to the power 2. And 3 is having a positional value of 10 to the power 3. And multiplying that number with its positional value and adding all these things, we are getting the value of the number. Now first we are going to see what is decimal number system. Decimal number system consists of 10 digits. We will be having 10 numbers, that is starting from 0 to 9. This decimal number system is having a base as 10. Each digit contributes to the value the number represents. The value contributed by the digits equal the product of the digit times the weight of the position of the digit in the number. So the digital decimal number system consists of 10 digits. The 10 digits are from 0 to 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So total 10 numbers we are having, that is from 0 to 9. And this decimal number system is having a base of 10 and each digit contributes to the value the number represents. The value contributed by the digit equals the product of the digit times the weight of the position of the digit in the number. The weight of the rightmost, that is rightmost digit is not, called least significant bit, and the leftmost bit is called most significant bit or most significant digit. The weight of the least significant digit is 10 to the power 0, that is 1. Now, for example, we are taking a number 375. So, this number is having a positional value of 10 to the power 0. This 7 is having a positional value of 10 to the power 1. And 3 is having a positional value of 10 to the power 2. So, 5 into 10 to the power 0 plus 7 into 10 to the power 1 plus 3 into 10 to the power 2. So, totally we are getting 375. Now, each digit contributes the value the number represents. The value contributed by the digits equals to the product of the digit times the weight of the position of the digit in the number. So, the value contributed by this digit 5 is nothing but 5 into 10 to the power 0, and value contributed by 7 is nothing but 7 into 10 to the power 1, and the value contributed by 3 is nothing but 3 into 10 to the power 2. So totally we are getting 3 into 10 to the power 2 plus 7 into 10 to the power 1 plus 5. That is nothing but 5 plus 70 plus 300. That is nothing but 375. Next number system what we are going to see is nothing but binary number system. In binary number system, we are using only two numbers, that is 0 and 1. And this binary number system is the simplest form of number system. A single digit is called bit. Bit is nothing but the short form of binary digit. This binary number system is used in computers. This binary number system can be easily represented by using a series of switch. If the switch position is off condition, then it is 0. If the switch position is in on, then it is 1. When 4 bits are combined together, a nibble is formed. 8 bits or 2 nibbles are combined to form a byte. So when you're having 8 bits, then it is nothing called byte. When you're having 16 bits or 2 bytes, then it is called word. When you're having 32 bits, then it is called double word. This diagram clearly shows what is bit, what is nibble, what is word, and what is double word. Now, one single digit, it is called bit. And this is the lowest bit and this is the highest bit. Lowest bit is called as least significant bit, and this highest bit is called most significant bit. And 4 bits combine to form nibble, and 8 bits combine to form byte, and 2 bytes combine to form a word, that is 16 bits combine to form word, and 32 bits they combine to form double word. Now next number system what you are going to see is octal number system. In octal number system, we are having numbers from 0 to 7. It is used in programming because of its similarity to binary number system. Since it is similar to binary number system, it is used in programming. A single octal digit is equal to 3 binary digits. Octal number system uses the base as 8. Next number system is hexadecimal number system. It consists of 16 digits starting from 0 to 15. This number is used for large numbers. If you want to represent large numbers, we can use hexadecimal number system. Hexadecimal number system uses the base as 16. For decimal number system, we use the base 10. For binary number system, we use the base 2. For octal number system, we use the base 8. And in hexadecimal number system, we use the base as 16. In hexadecimal number system, the numbers 0 to 9 are denoted normally. The numbers from 10 to 15 are denoted by alphabets A to F respectively. So, from 0 to 9, we are denoting it normally as numbers, and from 10 to 15, we are using the alphabets A through F. Types of number system. Here, I am explaining once more the decimal number system. It is having a base of 10 and it is using the numbers from 0 to 9. It is used by humans. We are using the number system. What we are using is nothing but the decimal number system, and it is not used by computers. In binary number system, it uses the base as 2 and we are using the numbers 0 and 1, and it is not used by humans and it is used by computers. Octal number system, it is having a base of 8 and we are having the numbers from 0 to 7, and it is not used by human beings and it is also not used by computers. Hexadecimal number system, it is having a base of 16 and we are having the numbers from 0 to 9, and 10 to 15 we are using the alphabets A, B, C, D, E, F. And this number system is not used by both humans as well as computers. Next, this is decimal number 0 and how we are representing it binary. So 0000 is a binary representation of decimal 0. In octal, it is represented as 0. Similarly, in hexadecimal, it is represented as 0. In 1, it is represented in binary as 0001, and in octal it is 1, and in hexadecimal it is 1. Similarly, 2, 3, 4, 5, 6, 7. Now 8. Binary value of 8 is 1000. In octal it is represented as 10, and in hexadecimal it is represented as 8 only. Now you come to 10. 10 is represented as binary as 1010, and in octal it is represented as 12, and in hexadecimal it is represented as A. Similarly, the other numbers. So now we are having this decimal number system, binary number system, octal number system, and hexadecimal number. Will shows the positional values of various. Now we are going to see the binary to decimal conversion. So to convert binary to decimal, first what we have to do is we have to multiply each bit by 2 to the power n, where n is the weight of the bit. So we have to multiply each bit by 2 to the power n, and n is the weight of the bit. The weight is the position of the bit starting from 0 on the right. So for the rightmost bit, the weight is 0. The next one, 1. That is for the rightmost bit, 2 to the power 0. For the next one, 2 to the power 1, then 2 to the power 2, and 2 to the power 3, and then 2 to the power 4, etc. Now, after multiplying each bit by their positional weight, we have to add the results. So this is the method for converting binary to decimal. First, we are going to see a problem how to convert the binary number 100101 to the base 2 to decimal. So first what we have to do means we have to write the binary number like this. After writing this binary number, we have to multiply each bit by its positional weight. So this bit is having a positional weight of 2 to the power 0. So this number is having a positional weight of 2 to the power 0. So we are going to multiply 1 into 2 to the power 0. Then we are multiplying the 0 with 2 to the power 1. Then we are going to multiply this 1 with 2 to the power 2. Then the 0 with 2 to the power 3. Then with 0 with 2 to the power 4. Then this 1 we are multiplying with 2 to the power 5. After that, we are adding all these values. So 1 into 2 to the power 5 is 32. 0 into 2 to the power is 0. 0 into 2 to the power is 0. 1 into 2 to the power 2 is 4. 0 into 2 to the power 1 is 0. And 1 into 2 to the power 0 is 1. So totally we are getting 37 to the base 10. So we have converted this binary number to decimal. Then next example, 1011 to the base 2 to decimal. First we have written the number, then we are multiplying that particular number with the positional weight. Then we are adding. So we are getting 23. So we have multiplied this 1 with 2 to the power 0, this 1 with 2 to the power 1, and this 1 to the power 2, 0 with 2 to the power 3, and 1 with 2 to the power 4. Then we have added and we have got 2 to 23 to the base 10. So we have converted this binary to decimal. Then another example, similar example. First we have written, then we have multiplied the particular number with its positional weights, and then we have added. So finally we have got 50. Then till now we have seen problems only having whole number part. So here you are having fractional part also. So similar to the previous problems, first we are written the binary number. Then the number after this point is nothing but the fraction part, and the number before this point is the whole number part. So the whole number part is nothing but 0 into 2 to the power 0, 1 into 2 to the power 1. But the numbers after this point, it is nothing but the the fractional part. Here the positional weight is 1 into 2 to the power minus 1, 0 into 2 to the power minus 2, 1 into 2 to the power minus 3, and 1 into 2 to the power minus 4. So we check that. So this is the so first you have to start from this point. So this is the fraction part. So the fraction part, the positional weight, first position it is having 2 to the power minus 1, and the second position it is having 2 to the power minus 2, and third position it is having 2 to the power minus 3, and fourth position it is having 2 to the power minus 4. And this is the whole number part. The whole number part, similar to the previous problem, 0 into 2 to the power 0, 1 into 2 to the power 1. After that, we are adding the whole number part separate and the fraction part separate. So the whole number part is 2 plus 0, and the fraction part is 1 by 2 is 0.5, 1 by 4 is 0.25, 1 by 8 is 0.125, and 1 by 16 is 0.0625. Finally, while adding, you are getting 2.6875 to the base 10. Now, next we are going to see the decimal to binary conversion. Previously, we have seen binary to decimal conversion. Now we are going to see decimal to binary conversion. So in decimal to binary conversion, what we are doing is we are dividing the decimal number by 2 till we are getting a 0 as quotient. So till we are getting 0 as a quotient, we will be continuously dividing that number by 2 and we will be recording the remainder. After getting a 0 as a quotient, we'll be taking that remainder as the answer. Now, one example, we are converting 22 to the base 10 to binary. So 22 is a decimal number and we are going to convert it to binary. So binary means 2. It is using only two numbers. So we are dividing that 22 by 2. So when you are dividing 22 by 2, you will be getting 11 as the quotient and 0 as a remainder. Again, we are dividing this 11 by 2. We will be getting 5 as the quotient and 1 as the remainder. Again, we are dividing 5 by 2. We will be getting 2 as the quotient and 1 as the remainder. Again, we are dividing 2 by 2 and we are getting 1 as the quotient and 0 as a remainder. If we again divide this 1 by 2, we'll be getting quotient as 0. So we are stopping at this step. And now we are going to record the remainders. That is 1, 0, 1, 1, 0. You have to write the answer from here to here. So 22 to the base 10 is equal to 1, 0, 1, 1, 0 to the base 2. Next, we are going to see another problem. We are going to convert 56 to the base 10 to binary. So we are having 56 and we are dividing it by 2. So while dividing 56 by 2, we will be getting 28 as a quotient and 0 as a remainder. Again, we will be dividing 28 by 2, we will be getting 14 as the quotient and 0 as the remainder. Again, we will be dividing 14 by 2, we will be getting 7 as the quotient and 0 as the remainder. Again, we will be dividing 7 by 2, we will be getting 3 as the quotient and 1 as the remainder. Again, we will be dividing 2 by 3, we will be getting 1 as the quotient and 1 as the remainder. If we again divide this 1 by 2, we'll be getting quotient as 0. So we are stopping here and we are recording the remainders and we are writing the answer. The answer is 111000. So 56 to the base 10 is equal to 111000 to the base 2. Then next we are going to see the conversion of decimal to binary for fraction. For to convert this fraction part of decimal to binary, we have to multiply by 2 and we have to note the carry. So repeat with a new fraction. Stop when the fraction part becomes 0. So now directly we will go to problem. So we are going to convert 0.7 to the base 10 to binary. So what we are doing is we are going to convert 0.7 to the base 10 to binary. So what we are doing is first we are multiplying 0.7 into 2, that is 1.4. Then we are recording this 1. This is the carry. Then again we are multiplying this 0.4 into 2, that is 0.8. Here it is 0, carry is 0. Again we are multiplying this 0.8 into 2, that is 1.6. Again we are recording this carry. Then again we are multiplying 0.6 into 2, that is 1.2. Again we are recording this carry. Again we are recording 0.2 into 2, that is 0.4. Here the carry is 0. So again 0.4 into 2 is nothing but 0.8. Again we are recording the carry, it is 0. So after we are getting this carry as 1, 0, 1, 1. After this the same thing is repeating. So we have to write the answer as 1, 0, 1, 1. Then 1, 0, 1, 1. So this is a 1, 0, 1, 1. Again 0, 0, 0, 0, and the same will be repeating 1, 1, 1, 0, 0. So please check. So here in this particular problem, it will not stop and it will continue. First, we are having 0.7 that we are multiplying by 2. We have got 1.4 and we have recorded the carry as 1. Then we have got the fraction as 0.2. Again, we have multiplied by 2, getting 1.6. We have recorded the carry. So after a particular thing, the same fraction part 0.4 is repeating. So up to this, that is 1011. 1011, you have to write and you have to repeat the same 01, again 1011. So 0.4 into 2 is 0.8. So in this particular problem, after getting 1011, so after getting 1011, this 0110 will be repeating. So first we are getting 0.7 into 2 is 1.4. Then 0.4 into 2 is 0.8. Then 0.8 into 2 is 1.6. Then 0.6 into 2 is 1.2. Then after that 0.2 into 2 is 0.4. So up to this 10110. After this, again the same is repeating. Again this 0.4 will be coming. Again this 0.8 will be coming. Again this 0.6 will be coming. Again this 0.2 will be coming. Again this 0.4 will be coming. So after this 10110, this 0110 will repeat. So after 10110, this 0110 will repeat. Why? Because this again this fraction 0.4 is coming once again. So since it is coming once again, it will be repeating. So the answer is 0 1 0 1 1 0 0 1 1 0 0 1 1 0. Next, we are going to see the conversion of decimal to binary for fraction. So the first step is we have to multiply the given fraction number by 2. Then we have to note the carry or the whole number part what you are getting. Then again we have to repeat with the new fraction. That is, we have to again multiply the new fraction by 2. Then again you have to note the carry. And we have to stop till we are getting the fraction part as 0. Now we are going to see one problem. So here we want to convert the number 0.625 to the base 10 to binary. The base 10 means it is decimal number. The first step is we have to multiply this 0.625 into 2. So we will be getting 1.25. Now we have to record this carry or whole number. This we are taking this as A1. Then we are multiplying this 0.250 into 2. So we are getting 0.5. We are recording this 0 as A2. Then we are multiplying this 0.5 into 2. So we are getting 1 as a carry, and here the fractional part gets 0. So we are recording this 1 as A3. Since the fractional part is getting 0, we are stopping at this point. Now we have to write in this order from A1 to A3. Now the answer is 0.625 to the base 10 is equal to 0.101 to the base 2. So we have converted the fraction 0.625 to the base 10 to binary. Now we are going to see the next problem. The next problem is convert 0.7 to the base 10 to binary. So this is a special type of problem. So in this problem, we will not get the fraction as 0. Again and again, some value will be coming and we will not get 0. So we can't stop. So after finding some values, we have to write the answer by repetition. So here the number is 0.7. So we are multiplying this 0.7 into 2. So we are getting 1.4 and we are recording A1 is equal to 1, 1. This is the carry or the whole number. We are writing it as 1. Then again we are multiplying this 0.4 into 2 and we are getting 0.8, and this 0 we are taking this as A2. Then this 0.8, when you are multiplying by 2, we are getting 1.6. So here we are getting 1 and we are recording this as A3. Then this 0.6 we are multiplying by 2, so we are getting 1.2, and this 1 we are recording this as A4. Then this 0.2, again this is a fraction, again we are multiplying it by 2, we are getting 0.4. Since we are getting 0, we are recording it as A5. Then again this 0.4, when you are multiplying by 2, we are getting 0.8, and this 0 we are recording it as A6. So in this particular problem, so first we are having 0.7. So while multiplying by 2, you are getting 0.4. So that 0.4, after multiplying with 2, you are getting 0.8. Then that 0.8, then when you multiply 2, you are getting 1.6. That 1.6, when you multiply 2, you are getting 1.2. And this 0.2, when you are multiplying by 2, you are getting 0.4. So this 4 is again repeating. So after you are getting 1, 0, 1, 1, 0. So after you are getting 1, 0, 1, 1, 0, this 4, again this 0.4 will be coming, it will be repeating. So you'll be multiplying this 0.4 into 2, you'll be getting 0.8, then 0.8 into 2, 1.6, then this 0.6 into 2, 1.2, and this 0.2 into 2, 0.4. Similarly, it will repeat. So the answer is, first you have to write 1, 0, 1, 1, 0. Then this 0.4 to 0.2, it will repeat. That is 0, 1, 1, 0. It will repeat. So in this conversion, you have to take from A1 to A6. You have to take. So how to write this answer in this problem is, first you have to write 1, 0, 1, 1, 0. That is 1, 0, 1, 1, 0. After that, this 0, 1, 1, 0 is repeating. 0, 1, 1, 0. Again it will repeat. 0, 1, 1, 0. 0, 1, 1, 0. So it will be continuing. So we are putting 3 dots and we are writing the answer. So this is a special type of problem. In this problem, you will not get the fraction as 0 and you can't stop. So it will be continuing. Okay. Next, so in the previously we have converted the whole number separately and that fraction part separately. In this problem, this number is having both the fraction as well as whole number part, that is 48.5625. You have to convert it to binary. So first you consider this whole number 48. You know that since we have to convert it to binary, so we have to divide it by 2. So when you are dividing 48 by 2, you will be getting 24 and the remainder is 0. Again, when you are dividing this 24 by 2, you will be getting 12 and the remainder is 0. Again, when you are dividing this 12 by 2, you will be getting 6 and the remainder is 0. The 6 again, when you are dividing by 2, you will be getting 3 and the remainder is 0. This 3, when you are dividing it by 2, you will be getting 1 and the remainder as 1. Again, if you are dividing this 1 by 2, you will be getting the quotient as 0. So we can stop at this point and we have to write the answer like this. That is 1, 1, 0, 0, 0, 0. This is the answer for this whole number part. Now then come to the fraction. So here you are having 0.5625. So 0.5625 into 2 is 1.125. Here the carry or the whole number part is 1. So we are taking A1 as 1. Then we are multiplying this 0.125 into 2. So we are getting 0.25 and we are taking this as A2. Then we are multiplying this 0.25 into 2 and we are getting 0.5. Here the value is 0. So we are taking it as A3. Then 0.5 into 2 is 1. So here the fractional part gets 0. So we are stopping at this point and we have to consider in this direction. So the answer is 1, 1, 0, 0, 1. This is the answer is 1, 1, 0, 0, 0, 0.1001. So this is the fraction part and this is the whole number part. So we have converted. So we have converted this 48.5625 to the base 10 to binary. So this is the whole number part that we have written here and this is the fraction part that we have taken from here. Next, a similar problem like that, 95.6875. So we have to convert this decimal number to binary. So similar to the previous problem, we are dividing 95 by 2. That 47 is the quotient and 1 is a remainder. And similarly, then we are dividing 47 by 2. That is 23 is a quotient and 1 is a remainder. Then 23 by 2, 11 is a quotient and 1 is a remainder. Then 11 by 2, 5 is a quotient and 1 is a remainder. Then 5 by 2, 2 is a quotient and 1 is a remainder. Then 2 by 2, 1 is a quotient and 0 is a remainder. If you again divide this 1 by 2, you will be getting quotient as 0. So we are stopping at this point and what you are getting is 1, 0, 1, 1, 1, 1, 1. Now you come to the fraction part. This fraction part you are having 0.6875. So first what you are doing is we are multiplying this 0.6875 into 2. So we are getting 1.3750. So we are taking this one as A1. Then we are multiplying this fraction 3750 into 2 and we are getting 0.75. Here the value is 0, that we are taking it as A2. And we are multiplying 0.75 into 2, that is equal to 1.50. Here we are getting 1, that we are taking it as A3. Then 0.5 into 2 is 1. Here we are getting fraction part at 0. So we can stop at this point. Then this is the answer 1011. So now we are writing the whole number part, that is 101111. And we are writing the fraction part 1011. is the answer. So this is the answer. Next is a similar problem, that is 0.6875. This is a fraction. Then we have to convert this decimal number to a binary number. The same thing. We have to multiply by 2 and we have to take the integer part and we have to save it in A1. Then again this 0.370 we have to multiply by 2. So we'll be getting 0.75. We have to take the 0 here, similar to the previous problem. So we'll be getting this as the answer. Now next one is we are going for octal to decimal conversion. How to convert base 8 to base 10. Now to convert to base 10, beginning with the rightmost digit, multiply each nth digit by 8 to the power n minus 1 and add all of the results together. So here we know that octal is nothing but 8. So what we have to convert, if you want to convert the octal number by into decimal, what we have to do means we have to multiply that particular number with the position weight. The position weight is 8 to the power 0 for the least significant bit, and for the next bit it is 8 to the power 1, and for the next bit it is 8 to the power 2, etc. Now directly we will come to the problem. We have to convert 1246 to the base 8 to decimal. So what we are doing is, first we are writing this number, then we are converting, we are multiplying the 7 with 8 to the power 0, then we are multiplying the 5 with 8 to the power 1, then we are multiplying this 3 with 8 to the power 2, then we are adding all the numbers and we will be getting the then we will be getting the answer. So that is nothing but 239 we are getting. So next problem is we are going to convert 1246 to the base 8 to decimal. So what we are doing is we are multiplying the 6 with the positional weight 8 to the power 0. Then we are multiplying 4 with the positional weight 8 to the power 1. Then we are multiplying 2 with 8 to the power 2. Then we are multiplying 1 with 8 to the power 3. Then we are adding. So we are getting 678 to the base 10. So what we are doing is the respective numbers we are multiplying with the positional weight and we are adding. Now next is decimal to octal conversion. So how we are doing is we are dividing the number by 8 till we are getting the quotient as 0. Then we are recording the remainder and we are taking that as the result. So next we are going to see decimal to octal conversion. So the division method we are using. So we have to start with our number given in decimal. Then we have to divide that number by 8. Since 2 to the power 3 is 8. So we have to divide the number by 8. Octal will be using numbers from 0 to 7. So totally 8 numbers. So we have to divide that number by 8 and we have to record that the remainder. While dividing, we will be getting a quotient and remainder, and we have to record the remainder. So we have to continue dividing till we are getting quotient as 0. When you are getting quotient as 0, we have to stop. If you are not getting 0, then we have to continue dividing by 8 till we are getting the quotient as 0. So in simple, we can tell us divide the decimal number by 8 until we are getting quotient as 0, and then we have to collect the remainder in reverse, and that is nothing but our answer. So now directly we are going to a problem. We will be clear with that. Now we are having a number 214. It is a decimal number that we have to convert it into octal. So we are dividing this 214 by 8. So we are getting 26. So 8 is 2 times 16 and 5. So we are dividing 214 by 8. So first you take 21. In 21, 2 times 16. So remaining is you are having 5. So 21 minus 16 is 5. So you are having 54. In 54, 6 times, that is 48 you are having, and the remainder is 6. So you are getting 26 here. Now again you are dividing this 26 by 8. So in 26 there are 3 8s, that is 24. So and the remainder is 2. So in 26 you are having 3 8s, that is 24, and the remainder is 2. If you again divide this 3 by 8, you will be getting the quotient as 0. So we can stop at this point. So the answer is 326. 326. So this is the answer. So this is an decimal number. That decimal number we have converted into octal. So what we have done is we have divided that number by 8 until we are getting the quotient as 0. Then we have taken the remainder in reverse, and that is nothing but the answer. Next is 4330. So here we are dividing 4330 by 8. First you take 43. So 5 times 40. 5 times you will be getting 40, and 3 is remainder, and then 33. In 33, 4 times 32, 1 is remainder. So 10. In 10, 1 8 is there. So 8 minus 10 minus 8 is 2 is a remainder. Now you come to 541. So we are dividing it by 8. So 8 6 are 48. Then remainder 6 is there. So 61. 61 7 times 56, and remainder 5 is there. Again you are dividing the 67 by 8. So 8 8s are 64. So remainder, here you are having 67. So remainder is 3. Again you are dividing this 8 by 8. You will be getting 1, and the remainder is 0. And you are taking the remainder in reverse, and you are writing the answer, that is 10352. So here what you are doing is you are continuously dividing the number by 8, and you are recording the remainders. After that, in the reverse you are writing the remainders, and this is nothing but the answer. Now next, here fraction. So how to convert this? Converting converting 0.64252 octal. So you're having a decimal number, we have to convert it to octal. So if you want to convert, this is nothing but a fraction. So this type of number system is octal. So octal means we are having the numbers from 0 to 8. So you're having 8 numbers. So what we have to do is continuously you have to multiply this fraction by 8, and we have to record that carry or the whole number, and we have to stop till we are getting the fraction part as 0. So first we are multiplying 0 5.64062 into 25 into 2, that is 5.125. Next we are multiplying, so we are recording this 5 as A1. Then we are multiplying this 0.125 into 8. So we are getting 1. So since we are getting fraction part as 0, we are stopping at this point and we are recording this carry or this whole number as 1. And we are writing in this order. And the answer of 0.640625 is equal to 0.51. So 0.640625 into 8 is equal to 5.125. We have recorded this 5 as A1. Then the 0.125, this fraction part, we are multiplying again by 8. So we are getting 1.0 and the fraction part gets 0. So we are stopping at this point and we are writing this 5.1. This is nothing but 0.51 and this is the answer. Next, so next we are going to convert. Next we are going to convert 0.513 to the base 10 to octal. That is, we are converting this decimal number to octal. This is a fraction and we are converting it to octal. So what we are doing is we are multiplying this 0.53 into 8. So we are getting 4.1044 and we are recording this 4 as A. We are making A1 as, we are taking A1 as 4 and then we are multiplying this 1044 into 8 and we are getting 0.832. Then we are recording this carry as A2. Then we are multiplying this 0.832 into 8 is equal to 6.656 and we are taking this as A3. Then we are multiplying this 0.656 into 8, that is 5.248 and we are making this as A4 and then we are multiplying this 0.248 into 8 and into 8 and we are getting 1.984 and we are making this as A5. So then we are multiplying this 0.984 into 8 and we are getting 7.872. Again this 0.872 fraction is coming. So this is a special type of problem and in this problem you will not get the fraction part as 0 and it will continue again and again. So we can stop at this point and we have to write this as answer and we can put 3 dots. The meaning is it will continue and this will not, here in this problem we will not get the fraction part as 0. So we can't stop. So it will again and again it will go. So after finding up to this point you can write the answer. Then next is hexadecimal to decimal conversion. To convert hexa is base 16, decimal is base 10. So we have to convert from base 16 to base 10. So we have to begin with the rightmost digit and multiply each nth digit by 16 to the power n minus 1. Add all of the result together. So we are directly going for a problem. This 1F4H is a hexadecimal number. I have already told you that in hexadecimal we are having numbers from 0 to 9 and from 10 to 15 we are having alphabets. So we are going to convert. So first we are writing the numbers and this is 4 and F is nothing but 15 and this is 1. Now this 4 is having a position weight of 16 power 0 and F is having a position weight of 16 power 1 and 1 is having a position weight of 16 power 2 and now we are adding and we will be getting the answer. So we have converted hexadecimal to decimal. Next problem, convert 25AC hexa to decimal. First we are writing the number. A is 10, B is 11, C is 12, uh, D is 13, E is 14, and F is 15. And we are multiplying each number by its positional weights. So C into 16 power 0, A into 16 power 1, and 5 into 16 power 2, and 2 into 16 power 3. Then we are adding all. 16 power 0 is 1, 16 power 1 is 16, and 16 power 2 is 256, and 16 power 3 is 4096. So while adding, we'll be getting 9644 to the base 10. Now we are going to convert decimal to hexa. So how to convert decimal number to decimal number? So here what we have to do is we have to divide the decimal number by 16 until we get the quotient as 0. We have to take the remainder in reverse as a result. So first we are taking 126 and we have to convert it into hexadecimal number. So we are dividing this 126 by 16. So we are getting, so in 126, 7 16s are there. It is nothing but 112 and the remainder is 14. So if you divide this 7 by 16, you'll be getting a quotient as 0. So we are stopping at this point. So and we have to, these are the remainders and we have to take the remainders. Now in hexadecimal, after 9, we have to use alphabets. So instead of 14, we have to use E and 7. So this is the answer. So next problem is we have to convert 603 to hexa. So what we are doing is we are dividing 16 by 603 by 16. So we are getting 37 and the remainder is 11. Again we are dividing 37 by 16, 32 and the remainder is 5. If we again divide this 2 by 16, the question will be 0 and we are taking this as this is the remainder that we are taking as answer. So instead of 11, we are putting it as B. So 2, 5, B is the answer. So next